8 useful tree data structure worth knowing. A tree is a hierarchical data structure which can represent the relationship between different nodes. Properties of a tree. A tree can contain nodes, no nodes, or it can contain one special node called the root with a zero or more subtrees. Every edge of the tree is directly or indirectly organized from the root. Every child has only one parent, but one parent can have many children. Parent, key, edge, and this is siblings, subtree, children, parent, leaf nodes, and the height of the tree. Terminology of the tree. There are the following 8 tree data structures with their usage: general tree, binary search tree, AV tree, red black tree, splay tree, trip, and B tree. General tree. A general tree is a tree data structure where there are no constraints on the hierarchical structure. Properties. Follow properties of a tree. A node can have any children, any number of children. A node can have any number of children. This is general tree. Usage. It is used to store hierarchical data structure as folder structures. Binary tree. Binary tree is a tree data structure where the following properties can be found. Properties of the trees. Property. A node can have at most 2 children. There are 2 children known as left child and right child. Binary tree. It is used by the compliers to build syntax trees. Used to implement the expression parsers and expression solvers. Used to store router tables in the routers. Binary search tree. Binary search tree is the more constructed extension of the binary tree. Properties. Has a unique properties known as the binary search tree properties. This property states the value of the key of the left child of a given node should be less than they are equal to the parent node, and the value of the right child should be greater than or equal to the parent values. This is the way to declare. Left side with the smallest value, right side with the greatest values. Okay, binary search tree used to implement a simple sorting algorithm. Can be used to priority queues. Used in many search applications where data is constantly entering and leaving. AVL tree. AVL tree is a self-balancing binary search tree. This is the first tree introduced which is automatically balances its heights. Okay, on the self-balancing. Properties is self-balancing. Each node stores a value called balance factor, which is the difference in height between the left subtree and right subtree. All the nodes must have a balance factor -1, 0 or 1. After performing insertion or deletion, if there is at least one node that does not contain balance factor -1 or 0, then the rotations should be performed to balance the tree self-balancing. You can read more about rotations operations. Balance factor 0, 0, 1, -1 of 0, 0, 0, 0, 0. Okay, I will take. Used in situation where frequent insertions are involved. Used in memory management subsystems of the Linux kernel to search memory regions of the process during the preemptions. Red block tree. Red block tree is a self-balancing binary search tree where each node has a color red or black. The color of the nodes are used to make the tree remains approximately balanced during the insertion and deletions. Okay, self-balancing. Each node is either red or black. The node is a black, sometimes omitted. All is denoted as nil or black. If the node is red, then both children are the black. Every path have given a node to any of its leaf node must go through the same number of black nodes. Okay, usage as the base of the data structure used in the computational geometry, used in the complete fire scheduler, used in the current Linux kernels, used in the ePOL system called implementations of the Linux kernel. Split tree is the self-balancing binary search tree. Following, okay, self-balancing. Recently access the elements are quickly to access again. After performing a search insertion or deletion, split trees perform on actions called a splaying, where the tree is rearranged using rotation so that the particular element is placed in the row. Usage used to implement caches, used to implement in the garbage collection, data compression. Tree a name derived from the tree plus heap is a binary search tree. Each node has 2 values, key and priorities. The key value of the binary search tree properties. Okay, this is a tree. Then B tree. B tree is a self-balancing search tree and contains multiple nodes with each node is in sorted order. Each node has 2 or more children